So welcome. That was a little weak, but we'll get better. This is the second Congress. The first Congress is Meutic Parataxis. I want to once again take the opportunity to thank our keynote sponsor, Geomagic through Ping Fu. Stop Badware, First, Microsoft, Siemens, Santa Fe Institute, Datura, and IronCAD. This Congress is really the only time we get together as an industry to have a joint conversation. There's lots of individual conversations that go on here and lots of discussions, but this is really the only time and place in the year when all of us get together to talk about what's going on. And we have one set topic and one open topic. Last year, the theme for COFES was the intersection of design and risk. We take that further, and instead of looking at risk, we're looking at resilience. Design for resilience in products and strategies. So at the DOS Symposium on Thursday morning, and for those of you who don't remember what the DOS Symposium is, it's big D, little s, design and sustainability. I proposed this framework for conversation, and that is we are trying to broaden people's context. Most decisions that are made in a very narrow context, whether you're thinking about a company or a vision or a location or a time scale or even a silo. What we want to do is we want to increase the awareness of the fact that the current context that we're looking at is limited and expand it. And the context is the frame for the discussion about what are the global trends and what drives those trends. And we talked a lot about that at the DOS Symposium on Thursday. But ultimately, trends have drivers, and drivers are driven by actions. And actions come from decisions. And decisions, whether a decision by a government or by an individual or a company or a conscious or an unconscious decision, buying this instead of that without thinking. Decisions are really the dials that we have, that we control, that push the drivers that drive the trends. Now, for most of us, we are in the tool business. We provide tools as a software industry for those who create the world around us. We provide the tools for designers and engineers. And it's our opportunity to build the tools that can allow our customers to create or to make more informed decisions so that the drivers and trends will put us down a path that we are more likely to want to go. So we heard from Xander on Friday about long-term, really long-term resilient thinking and all of the really tiny ways that things can go wrong over very, very long periods of time. We heard from Esther about how context and culture can drive significant improvements and survival across economic times. We had lots of discussions here. We had great discussions on the briefings yesterday. I'm looking forward to hearing something about what happened in terms of the discussions that happened today. But what I really want to know is, from coming to COFES, how has your context shifted, and where do we need to go from there? And to join me in this conversation, I'd like a warm round of applause to our friend Peter Marks. Peter?
One of the things that we find here is that each of us only has a chance to cover about 10% of the program, maybe even less than if you cover things. So the first thing that I'd like you to think about is there's probably been one or two things that were kind of aha moments for you. You know, something that you took from a presentation, you took from a discussion, something that just, you made a note, you put a star on it, you say, I'm going to be thinking about that. And I thought that we might just do a little bit of just, from all of us, just what were those things? Now, we're all probably at the stage of I haven't quite fully digested what's going on here, but I'm going to ask you to speed up your digestion and the next, so this is kind of like a, you know, two sentences, real short, just something that just hit me that I hadn't thought about before. Anybody? And who's got the mics?
We've got mics on the aisle.
And your thought. So Scott?
Yeah.
Not before.
I'm waiting. I know better. I saw the chastisement earlier.
I'm still trying to figure out what it's going to mean, but the thing that impressed me was the guys from New Mexico talking about the way their sorting algorithm and the robustness of it, where they were able to suffer massive data loss essentially, and it would repopulate itself. It was very robust, and it got me thinking about genetic algorithms and how those may be a better way to, earlier in the design process, make choices instead of some of the deterministic tools that we use now. And I haven't figured out how that fits into what I do, but I thought that was pretty cool.
That's
So
cool,
that was
that's
my
great,
aha.
that's a good one. Anybody else?
David.
David, yes. Here, I can, if somebody gives me a mic, I'll run around too.
I think that what I heard yesterday afternoon from Nell and Nathaniel of radically changing a $360 billion clothing industry, come back in a couple of years, and I think they're going to have quite a story to tell us.
Yeah, a lot of great presentation, that whole thread. Anybody else? Over here, yeah. Richard? Right.
Excuse me. I actually learned something this week about millennials from a very smart millennial and from somebody that's actually older than I am. I don't know how it's going to affect me in my work, my business, but it's going to change the relationship with my kids.
Cool, yeah.
Okay. Rick?
Others?
Okay, the theme is resilience, and I have a major problem with what a lot of people think resilience is all about. But one thing that was a major breath of fresh air was Xander's recognition that resilience isn't something you just design in at design time, but something you have people who maintain continuously.
So speaking on resilience, everybody has their 10,000 year pass key for your hotel room. How many of you have had trouble with the magnetic strip not being? Yeah, so just FYI, we, you know, the engineers think of the best things, but there's something different, isn't there?
Peter, I'm going to step in here for a second.
Chief engineer, I knew this was coming.
You need a baseline.
That's true, that's true.
For those, how many of you here were here last year? Just everybody who was here last year. Okay. Those of you who did not have a problem with your keys last year, raise your hand. Did not? Okay. And how many of those who did not have with this year, raise your hand? So the keys this year were all fresh, and they were a smaller percentage had problems.
Pardon?
Can we talk about the lizard?
All right, so we shall know. Other things, go ahead, Mike.
The thing I think I liked most was in Xander's talk, the actual detailing the various mechanisms that we could use to address that long-term viability. Not just maintenance, but that they'll bury it underground. I like the thinking that went into coming up with a list of these kinds of options, and that list kind of stimulated some thoughts for me.
Yeah, I thought that was terrific too, but there's also this mutual incompatibility, like like have a cult maintain it while it's buried and sealed underground. And
Yeah.
That's cool. Please, Bill.
So yeah, I want to. One thing from the millennial discussion I learned today is that people no longer use their finger or their thumb to ring a doorbell. They send a text message to the person inside. That was a complete revelation for me.
Yeah, very cool.
But the other thing I learned from a business side that I've picked up from this is, you know, as we're evolving some of our business models to some of the changes that are happening in technology and stuff, is are we really making sure and taking care that our customers still understand the true value of the tools we provide? And that's
Good
something
point.
I've picked up.
I think we've got a, yeah.
This is on context, and just what Brad just did here with their hands raised in the room and understanding the problem. And I, am a slave to requirements right now, and really understanding the whole problem was a big takeaway.
Yeah, the whole problem, yeah.
2 was I really got an understanding this year that they don't care what you say. I can tell them what I know, and they don't remember, but I can tell them what I feel, and they do.
Good point. Other kind of big takeaways from anybody? Back here.
Okay, I really, Xander Rose's idea of having valuables to create resilience was, it was something which I even never thought of. And I kind of linked it to why then Indian women wear a lot of ornaments on them. So, it's like, I couldn't, I was thinking of opposite, that you would not have anything on you to preserve yourself, So that was something which was very interesting.
Great, thank you. We've got time for a couple more if there's.
Back here?
Oh, here, yeah.
Go ahead, Dave.
So a couple of things in terms of challenges to the industry in terms of software. Number one is how can the software industry improve the software to allow this notion of resilience to become systemic as supported by software rather than trying to guess on how to do it by yourselves. The second is that the advent of parallelism has an extraordinary impact on what this particular industry winds up doing. Yeah, I'm going to be a keen observer to determine how long it actually takes to actually take advantage of that parallelism.
My takeaway is the importance of human interaction. We're talking a lot about email and a lot about Twitter, and sitting at lunch, I happen to talk to Chuck and say, do you remember Joe Greco, what a great guy he was? And his wife is somewhere here, so there's Heather.
Jack?
In the context of the last several years, in which it appeared to me most of us were striving to say what we know, this year really struck me about the number of people interested and willing to detect what they don't know and readiness to learn.
Yeah, the millennial thing was a good example of that, yeah. Anyone else that wanted to?
I want to point somebody out here.
Yeah.
Ferris, stand up. Get a mic.
This is one me.
So Ferris, right after the Nayudik Parataxis presentations last night, we were talking about Bhaskar Saha's presentation, from Park about fault modes. And you made
Is this a test? Don't do that.
You made the comment about what happened at NASA with the differential, or maybe it was Nathaniel.
I was about to say.
Yeah.
Nathaniel, this is you. Okay, great.
Is this... Check. Is this a test?
Yes. Can you describe the problem that we talked about with the breaking of the ribbon because of where the text was printed? satellite failed.
I think it's on. I think it's on. I don't remember what the satellite is, but it's been on orbit for about. It's been on orbit for about 20 years and designed for a 10-year life cycle. And we're still getting great data. I think it's Calypso. It's still getting amazing data out of it, and I think it was Calypso. Anyways, there's a wire. So there's a gimbal, and there's a power bus, and the power bus went down. So there's a part of the instrument that went down. The reason the power bus went down is because a wire broke. And the wire, there's these when you have an axial joint, you'll take a ribbon and you'll put the wire in the ribbon and run it around that axial joint so you can turn it. And the wires are laminated in that ribbon. And they went through all the testing and qualification, and then this power bus goes down, and they figured out, oh, it's got to be here. So they go through and they pull out of storage the flight unit, the flight backups. And they found out that some of them had printing on the plastic, and some of them didn't, where the copper traces were. And I just happened to be in this review. My mentor had said, go to these reviews and see what you can learn. And so this is like way above my pay grade. It's not my problem. But it is. And what happened was they had some of the devices, some of the ribbons had the serial number or the part number printed only on the plastic, and some had it printed over the plastic and the wire. And the ink from the printing had embrittled the copper under the printing. Thermal and fatigue had cracked the copper directly under the ink. And this is one little teeny component. This is just a wire component in a whole satellite. You build a whole satellite bus. And why didn't we think of that? And so when I was talking to Bhaskar about, he said he really, really believed that he could model everything because everything comes down to physics. And I'm like, I know, but I can't believe that because I work in the real world. And
to which Faris pointed out,
all right,
this goes to memory, the fact that you can't model everything. But the real issue is every time we run into one of these investigations, we increase the percentage of things that we can capture and have foresight on. And it's not that we will ever capture everything, but the amount that we are unable to foresee goes down. Very long story, very short point. Next question.
Any other, please, Jonathan, get a mic here.
Debunking?
Okay, oh, sorry, yes.
One thing I noticed was, at least over the last couple of years, this industry as a whole has been talking a lot about cloud, and cloud deployments, what should go in the cloud, what shouldn't. And this year at COFES, there were a couple of different sessions around cloud. What I understood, because I was a part of both those roundtables sessions, was, and there were a lot of intelligent people in the room, as is there here. I think even though it seems imminent that everybody's got to move to the cloud, there are benefits. I still think there is a lot of, it still is very nebulous, as the term it should be. It's like cloudy. And everybody has their own interpretations on cloud, remote, the benefits. So I think even though it seems imminent, it's going to be a while before everybody actually moves there. Because I didn't see consensus in a lot of the things that we discussed around the cloud.
Thank you. So thanks for this. I'm a first year, so this has been a great event for me. I can't pronounce either of the two words from the session yesterday.
Parataxis.
But in that session, I love the stuff on data exhaust and how to repurpose data for new purposes. We do a lot of surveys. We have a treasure trove of data, and it gave me some thoughts on how we can repurpose that and learn some new things. So thanks for that.
Yeah, thank you for noting that one. I think any other things to sort of get off our mental chests? Or alrighty, so maybe just click on. So I've been grappling with kind of trying to figure out a framework for some of the discussions we've got. And it's far from perfect. This is the typical collapse, 5 variables onto 2 dimensions and put it on a 2x2 matrix, even though it's a gradient. But I'll give you a rough start at it as a way of sort of kind of classifying the discussions, the issues we've had. So if we take certainty ranges from 0%. Not only do I not have a clue, but I'm the guy that always gets in the wrong line and has never won, so it's absolute inability to predict anything. And 100% certainty, which is not achievable, is at any infinite time in the future, with any infinite number of variables and multi-fixed problems, I can tell you exactly what's going to happen. You will have 0% key failures because I've predicted that. Everything's going to be perfect. So on the certainty axis, we have really spent most of our life in the industry trying to go from 0 closer to 100. So today we thought, if you have more variables, if you have more powerful computers, if you've got a supercomputer that's got 5 dimensions, if we have model-based engineering, if we only had 3D instead of 2D, if we could just get rid of David Ullman and his idea that things are uncertain, and we, that we would be able to make models big enough to predict every single thing that's going on, and therefore optimize things. And the more ambitious we are, the more variables we've got and stuff like that. Now, the stakeholder served one is the one I'm having a little difficulty with, but if you think of this kind of human greed versus altruism as drivers, and the way that expresses itself is sometimes I'm interested in just me. I'm Donald Trump, and me and my hair are all that matter. I care about my family, I care about my community, I care about my nation, I care about engineering, I care about the education of kids there. I'm Ken Hole, and I care about the biosphere because I know that the bacteria in my gut and the complex soil composition, I know that there's so many variables interact. They're all important. So we're looking at number of stakeholders adequately served. Now, obviously, the more stakeholders you put into the equations, the harder they get to solve. And so we kind of end up in what I'm going to call 4 quadrants. In the quadrant in which there are at least 2 powerful stakeholders and very little understanding of what's going to happen next. If it's like North Korea in the United States, and we both got nukes, now how do you like that? We ended up in a conflict kind of dominated scheme, sometimes with compromise and the rest of that, but it's like manufacturing versus sales or marketing or whatever, and we try to calculate our way out of that box by beating up each other and being the boss and stuff like that. Now, to the extent that we can, whether it's 2 stakeholders or 5 stakeholders, or it's the healthcare system, we actually care about our customers, to the extent that we can identify a fixed number of stakeholders and calculate the best overall thing or what we're going to get, then in fact we can optimize a system. Kind of with me on this? Makes sense? So I think we've been kind of spending most of our COFES lives trying to move from conflict to optimization. The thing that strikes me as new this year is this recognition that there are far more stakeholders who have a role in a mutual win-win situation. A lot of this in the DOS Symposium that we really need to account for. And because we're not good at accounting for that, sometimes we compromise, but more often we end up with diversity. So if you look at how is the human genome robust, how are civilizations robust, they're not, when you optimize, you end up with a monoculture. You end up with one answer is the best thing, everybody should have a Model T, and that's the way you go. When you end up with many stakeholders on certain requirements, you end up with a whole bunch of cars, multiple cultures. Okay, I guess it's okay if you're gay. You end up tolerating diversity, maybe even celebrating diversity in this space. And sustainability, and when we've seen this difficulty of optimization gives these very efficient but brittle systems. Diversity is a little bit like, I forget who made the point about the robust algorithms and things like that. That's another, those are 2 different kind of computing sort of ways that when you have more stakeholders, you allow more uncertainty, you know that we can't predict everything, then you end up celebrating multiple items. You have markets with multiple entrants. You have multiple cultures. You have so anyhow, it strikes me, and sustainability seems to be this nirvana where we serve every stakeholder down to the loneliest, bacteria in our gut that somehow is helping us, or distant Klingons that have been helping us. We don't know. I mean, it's a very broad scope, while having full knowledge, and we create systems that are some ideal, master mix. Now, it's not a perfect framework, but just it struck me as one way of kind of capturing the challenges that we face. And what for me was different, having missed a couple of COFESs, was for the first time I'm hearing, no, there's other variables. There's other variables. I mean, Rick, you had this kind of this genetic approach is another way of admitting other variables, admitting we don't know what's going on. But there's still, like when we talked about, as long as we know the physics of the problem, we can figure all the failure modes and we'll figure our way out of that. But if I ask you, where do the most common failures in any system come from? It comes from the people involved. And some of them don't even care to be educated on F equals MA. So they're not going to be acting physically for us. So anyhow, that was just a thought. And I don't know if it stirs, any thoughts, comments, wrong axes? Yeah, go ahead, Rick.
Yeah, I'm
Wait. He's going to tear it apart as well deserves to be, because it's multiple axes condensed down to two.
It's a really good lunch sketch.
I'm concerned about the stakeholder issue that
Okay.
you bring up, and I appreciate the point you made of it, and that's with a certain kind of stakeholder community, all of whom have some knowledge of the whole and the benefit for all of us, and what I have to compromise for someone else in order to make the best
Or
work.
not.
Or not. Then I look at the F-35 strike fighter, and I say the problem there is we had too many stakeholders,
Right.
all who got an arm in the water and had to be dealt with, had to be respected and get what they wanted. And so just having a lot of stakeholders isn't enough. There has to be something about that community of stakeholders.
Yeah, and if I could agree with you on that, my conclusion, this is one of the problems, is that there isn't an equation that optimally solves all the stakeholders, like that the fighter is not optimal. What you end up saying is we have to have more than one fighter. We have to have diversity in order to satisfy these diverse requirements and have a resilient system. That's the state we end up in. There were some other, over.
Ken Hall. It's a struggle sometimes because we all approach these things from different perspectives. It's ironic that you put that up because I was planning on offering a thought, and I can't believe how well it mirrors this. I've had some frustrations as we've been talking about resilience. And I know that there are at least two different definitions to resilience, and I think it's important to realize that there are at least two. We haven't even really defined what the word is. But I had to go out and Google it, and I still don't quite have it right. And there's a white paper on this written by a biologist, a systems theorist. So let's take engineering resilience first and think of it as optimized. I just have a few keywords. So when you have an engineering resilience approach, you're looking at efficiency, constancy, predictability. You're looking at stability near an equilibrium. Think of a structural engineer. He wants his structure to be resilient, but he's working with something that's near an equilibrium. You're looking at a steady state system, and you're looking at resistance to the disturbance and the speed of returning from that disturbance. On the other hand, and this is the way I approach it, I tend to think of it as ecological resilience, which is the right hand. And that is, and ecologists are worried about persistence of systems. They're worried about change and unpredictability. They're worried about conditions which are far from equilibrium. And in particular, they're worried about instabilities in systems that can flip them into entirely different stability regimes. And this can be applied not only from an ecological systems point of view, but it's also applied to social systems, because ultimately there's a lot of similarities between social systems and ecological systems. So I wanted to offer that. I think it's really important that we think about there are different ways of thinking with these words, and so we oftentimes have a hard time actually communicating with each other.
Yeah, just to echo that, on this kind of like lower diversity requirement in a living system, you can't have a monoculture for it to be robust. You have to have genetic variation. You have to have failure for it to evolve. I mean, it's literally saying you don't have a good system if you want to live in this quadrant unless some of your buildings die. And so it is a different kind of approach. Yeah.
Just a really quick comment from a control standpoint. If you have all of your design criteria, no, stability. Oh my goodness, my words just left me. Poles. If you got all your poles off to the left-hand side, everything's very stable. But the problem with that is you can't move. And so you always have to have instability built into the system in order to make it so that you can actually maneuver.
Yeah.
So
that's good addition to that.
So I'm going to step in, as I get to do. The working definition that I've been working on, as we've been talking about for COFES, is the ability to thrive when the initial design conditions change.
So that kind of puts you in that lower quadrant.
No, actually, it puts me, I don't care about the certainty. All I care about is when the conditions change, I have the ability to self-reinforce and to adapt to the new condition.
Yeah.
And if it goes back to the existing condition, I can do so without damage.
Yeah.
Why don't we pick up one back here and then we'll come to the front.
Yeah, I just want to remind people of the saying that all models are wrong, some are useful, and I didn't invent that. Somebody a lot smarter than me came up with that. But it's if we're going to really concentrate on proliferating far more modeling and simulation, not just at the top end, but broader on more industries and more people doing this type of work, there needs to be some at least recognition that that's the truth. And we keep talking about optimization, and even if we include stochastics and we can capture more of the resilience, these models are still wrong.
Well, let's go back to Esther's example for the airlines. It's a very clear picture. You can optimize to get everybody as efficient as possible in perfect conditions, but the system breaks when something isn't perfect, when the weather changes or a plane goes down. Or you can optimize to adapt so that you have the resilience in the system or the room in the system to get the overflow, but then you're suboptimal in terms of what the revenue is, and there has to be a balance between the two. Mike?
The thing that I think about when I think about resilience is not rapidly returning to stability, it's rather the ability to flourish in an environment of constant change and mismatch. That a resilient system rides the waves, rides the thermals, the way the birds do or something. That sense that you don't need the stability to flourish. That's what resilience means to me.
I think we had another. Bob?
I was thinking about the keynote yesterday, which was great. I can't remember how long that cement ceiling was up there, and it cracked, and it still stayed together. It was still sustainable, if you will, today. And that made me really think that you sort of don't know what you don't know. You know, I didn't know that, and I'm not sure if that's common knowledge, that if you have small particles in the concrete with rocks and so forth, you can have cracks and still have a sustainable ceiling for hundreds or thousands of years. And it made me think of Darwinism type of thing, you know, survival of the fittest. And that was just a point in observation.
Cool. Bob, one of the things about that is we can think about a portion of the conversation on resiliency, and particularly on design for resiliency, is embedded design to fail gracefully. One of the reasons why we haven't had very many inertial batteries, you know, high speed, because when they, for most materials, when you get enough energy in there, when they fail, they fail explosively or dramatically, and it's kind of problematic. That's changing, but as we learn how to design to fail gracefully, like when the brakes go out and nothing's happening, you have to have some sort of way for the system to actually not kill you. Scott.
It's because I've got a really nice voice. He says I talk a lot. Truth hurts. So as I'm listening to some words said here, the definitions of resiliency, I was sitting here thinking, okay, I mentioned robustness, but then some of it's really resiliency, and then you mentioned brittleness, and I thought ductility, and I hear sustain damage and still work, and I hear change, and so I'm trying to figure out how to put this paradigm of robustness and resiliency in terms of damage resistance and damage tolerance. I'm just throwing that out there as a thought.
John?
So the F-18 is a phenomenal fighter, but every once in a while a wing gets blown off and the airplane crashes. There was, I forget which university did it, but they did a study and they built I don't know, about a 6 or 8 foot model talking about surviving and failing gracefully. They built about a 6 foot scale model of an F-18, and but in this model they they designed it so they could blow the wing off at any given point. And when they did that, they put a control system in there, and it would instantly change all of the control state variables, figure out what the steady state of the aircraft was, and then fly the aircraft in that steady state. The pilot wouldn't even change how he used his controls, and he could still fly home on one wing. So that's, I think, an example of gracefully failing, even though it was a catastrophic failure.
Yeah, so maybe if I could just kind of bring us to a close. I think the issue that's facing us is that we would love for there to be a closed form solution to sustainability. That there is an answer, and it's an optimal answer, and that if our models are big enough, we can get there. And the actual situation I think that we face is that our models are getting better, our ability to incorporate more variables is getting better, and probably one of the penultimate examples is flying with one wing. It's like that's an example of the optimization culture taken to consider a lot of failure modes, just like we've designed buildings with earthquakes and stuff. But given that we don't have certainty, given that we're not omnipotent and stuff like that, we are still going to have failures. There's no certainty of a 10,000-year clock, much less an infinitely long clock. In fact, it's certain that the clock will not be around for an infinite period of time. So the other design philosophy is more like organisms that have genetic variability, that fail, that replicate if they seem to be doing good, but preserve variability and so on. So I think we're a group in search of a single answer that may not have it. Jack, what do you think?
I'd suggest that we each go look up the notion of indeterminate systems, because most of the conversation I'm hearing is people understanding that what they've been doing for years and designing for things they knew were going to work a certain way are now puzzled about what to do about things that they're not quite sure are going to happen. And the word, one term for that is indeterminacy, right? The people in India 2,500 years ago built a little training aid for that. It's called chess. And the white player and the black player don't quite know what to do next, right? What's going to happen next? And there are several instances now of indeterminate systems. And as Colonel Boyd said, you see, why the YF-22, if you're going to deal with an opponent, there's only two things you have to do. You have to dump kinetic energy faster than he can, and you have to gain kinetic energy faster than he can, right? And if you do those two figures of merit, then no matter what they do, you will not necessarily win, but you will not lose. And there's where the mental image comes, I think, in this group, is that we've all been striving to always win. And now we're faced with a situation where we may have to agree in our life sometime that it's okay to just draw, right?
So we've got another comment, Chris?
Well, one thing is you should all have been in our session on fragility, because it sounds very much like we're doing a lot of the discussion that we had there. For those that were there, they will certainly recognize that. But one thing that strikes me is we're talking a lot about the outcome. We're talking little about the path, or at least that's the feeling I have. And so I wonder if it wouldn't be useful to shift the focus to the design principles that will put us on the way to things, instead of talking about the things we want to achieve. It's just an idea.
So I want to shift the conversation a little bit from the generic things to actually talking about resiliency of software, because most of you in this room have companies that design software that the larger it gets, the more fragile it gets. Now, Mike gave what I've heard is a brilliant talk on Thursday about a different way of thinking about software that is, by its nature, less fragile, if you will. I also wanted to point back to what Esther said when I asked her about her track record of investing. And she says the best way to have a great track record of investing in successes is just ignore the fact that you have all of these other failures along the way and just keep on pumping out, and eventually things will hit. So Mike, I'd like to call on you for just a second to comment on the current challenge that we have for software fragility that we're building in.
Fragility comes not just from size, but from change, from things perturbing our systems. When we build one model of software, one sense of how people will work with it, that's where we start building in this sense of fragility. When we try to make that system deal with a lot of changes in how people see it, how they use it, the operating systems it works on, these things become non-adaptable. We don't write our software to be free of influence from them. The idea I had of encapsulating pieces of the design was to isolate them from these sorts of perturbing factors. And I think that's perhaps one way of approaching improving the sustainability or the adaptability of our software.
So just a show of hands, how many of you in here are certain that the fragility of software in your firms is not a problem? Because I know if I ask the question the other way, nobody's hand's going to raise. So just Shimon. I'll say it again. Oh, and Lars from Synopsys. So Lars, I'm going to hand you the mic. And
yeah. So you're asking now about the engineering software, the engineering software and the fragility in there, and yes. The goal is to remove the fragility in there. Well, I think in many of the cases that we have, and I don't want to give you the impression that we have bad software, but some of the software and some of the things that people want to do with it is really, really leading edge, and the software can actually break and you can go fix it because they are at the leading edge and you need to give them somewhat green software sometimes. Well, it's the banana principle that you ship it green and it matures with the customer. But actually the customer would not be willing to wait until they would receive the software that would be bug-free, because by the time they get that, well, what they design will then afterwards be too late. But the engineering principle, shouldn't it be that what you design is then actually robust? I mean, why talk about the software?
So the reason I talked about the software is because that's what you all do. What we started the conversation about was what is used with the software, and I was just turning it the other way. But I'd be happy to go down that road some more. But I do want to point out that the tools that Synopsys creates, by definition, the domain that you work in are things that are very, very in front of what has to happen, because they need to have your tools before they can design the next circuits that are going to be created and built before they go in, that then our clients actually will then be able to write software for to run systems. And so I suspect that there is a trade-off between the fragility or the maturity of the software and, or let's just say tolerance for exceptions in exchange for exceptional advantage. And if we get 5 steps forward and 1 step back, we're willing to take that rather than to get 1 step forward, 1 step forward, 1 step forward.
Just an additional comment on fragility. It's really in the product, because, well, we could have green software or whatever it is then, that doesn't work. But on the other hand, I think in the semiconductor industry, you have more verification that actually what you're designing afterwards works. That's one of the biggest parts of the business, that you afterwards run it and make sure, because you cannot afford that the chip afterwards doesn't work. So maybe it's not so much in the design, but also the verification part that you should look at.
Thank you. Anyone else? Rick? Oh, no. Shamal.
Switch here. Yeah. I was thinking what Mike just said. In our case, we build a software. It's really a calculator. And we did a lot of work up front to forecast the need of the user and the experimental codes and all. And then we made it very clear that this is not subject to change. The inspiration came from the HP12C calculator. I don't know how many years it's been around. It is a calculator. Everybody knows how to use it. There's no rev changes, nothing like that. So as a result, the software is very compact. And I hope people are using it, but I have thousands of customers. We haven't received a single field reported bug as yet. Yeah. So the idea is, sometimes you may fix the expectation of the user that this is not whims and fancies, because you react to those whims and fancies or needs without discipline. There is a direct relationship on the fragility of the software solution.
So, yes, Mike?
Probably shoot myself in the foot here, but one of the things I just thought, listening to the answer and a couple other things, is that we pay a lot of attention when we design our products to our customers need. I wonder how many of us in that design cycle really think about resiliency when we're doing the product design, that perhaps we really haven't paid enough attention to those concepts, that we're a little too customer focused.
So I just want to take a little survey. For those of you well, actually for all of you, when you are thinking about your next generation product, you've got your current version of what you're working on, and I don't care whether you're working on a car or a piece of software. Then you've got the version that comes after that is usually in somebody's working on. But then somebody in the company is working on a longer term vision for what you're doing. What I'd like to do is to get a survey. How many of you, for that last version in your companies, are looking as many as 5 years down the road? Very few. How many 3 to 5 years? How many less than 3 years? Okay, how many didn't raise your hand? Okay, and how many are looking as far out as 10 years? Yeah, but,
Yeah.
one of the things that I've been trying to do with COFES is to get the thinking of what we're doing to consider the longer term viability. I think Jeff Bezos has done a very, very good job talking about what makes Amazon a success. Is he's been able to, from the very beginning, talk to his stockholders about the fact that the investments we are making today, we don't expect to see revenue from for at least 7, if not 10 years. And the further out that we can push the investment so that we can do things now that aren't easy, but that change the industry, the better off we will be, as long as we can survive in the meantime. And one of the things that I want to talk about is, it's not necessarily the right thing that all of us survive as businesses in the meantime. We've seen tremendous transition over the years in terms of businesses, and some businesses thrive for a while, and some businesses, they come and they go, and very few businesses go on and on and on and reinvent themselves. But this reinvention process is key to all of us as an industry moving forward, and I think that we need to be considering that. Now, as we come towards the end of this conversation, one of the things that I wanted to do to get from you is to understand not what happened here and how great the conversations were or how terrible the conversations were, but what should we be talking about? What is the conversation that really has meaning to you as in your role within this industry? Peter.
Well, if I could just make a kind of a devil's advocate kind of comment here. So I've had the virtue of kind of missing out a little bit of time. And it seems to me that we're doing a little bit of forecasting the future in the rearview mirror. We're surveying our customers, and they really like what we're doing if we'd only add the following features. We're continuing to follow Moore's Law. You know, we're doing all the stuff we should for our current customer base. But the future isn't a bunch of old gray-haired guys with 25-year-old mechanical engineering degrees who really are happy that we've got a great 3D system. The future is kids that have not yet graduated, who we've learned through most of the world, through Brad's survey stuff, see work as mobile, particularly in China, but every place else, who will want these capabilities on at least a tablet, maybe through a screen, who will wonder why, since in the architectural world, you know, where we are is so important, why don't we have differential GPS, since it now costs the cost of, you know, 2 phones, you know, one put on a standpoint, the kind of application that you've done. I mean, if you think of all the sensors that come now for almost for free with the new mobile applications, we can put an accelerometer in place for a year and find out if we live on a fault zone. We can add temperature to it. So there's just this incredible opportunity to serve not the people we've been serving now. And then you sit through Jay's talk and you go like, we're maybe a $10 billion industry growing at 7%. And if you look at our market cap, that means like every 2 years somebody starts from 0, and in 2 years they've got a higher market cap than the entire, you know, industry. So and it's not that we all should follow that. I mean, there's some of us that will live our lives gracefully out, you know, offering solid something or other version, you know, 17.9. But there are these absolutely green fields for us to be thinking about, and some of us will be like IBM, reinvent ourselves, you know, 3 or 4 times over the year. And so what I would add for next year is, what are the opportunities for that reinvention for those that want to spend the effort in that?
Rick.
Just to elaborate on what Peter just said, one of the things I love about coming here to COFES is everybody's working on something slightly different that I haven't thought of, or they're approaching problems from different perspectives, and it's great, because that's how innovation happens, right? There's kind of like these different problems and solutions that don't normally cross paths get this opportunity to intersect. And again, I love that. I would actually say we should broaden this a little bit, and to other disciplines, other industries that have even just remote relevance to the things that we do in this space, as a way to kind of inject new ideas beyond kind of the things that live in this space.
Alan?
Can I ask a question? Right, so the question might be a bit controversial to you, Brad, but the question is, how many people here would like the opportunity to fill in a feedback form to suggest what's good, what can be improved, and perhaps where we can go, where we can take this next year? Because I think the forum is great.
So send them to Alan.
So hands up.
Email address.
Absolutely. alan.behrens@taxel.com. I'm delighted, and I'll compile them for you, Brad. But because I think what Rick was saying is good. I think there's a lot of people with some good ideas, and there's more that we can do.
So I appreciate that, and I look forward to what happens out of it. And Rick, your comment as well, but that really wasn't the question that I was asking. Well, I wasn't asking what should we do next year and what questions should we talk about next year. I'm saying we have an opportunity right now. What should we be talking about? Not what might we be talking about then. What should we be talking about now? What did we miss from this conversation that is important that we should be discussing? And if there isn't anything, I mean, we did a great job, and but I can't imagine that there are topics out there that we should have covered that we didn't. Chad.
There was one topic that actually came up on several days for me in several different sessions, and actually, Matthew, we had talked about this on the first night. The whole idea that by the time you start using CAD, all the major design decisions have been made, right? That CAD really isn't used to engineer products, and that there are tools that could be developed before that that would add great value. So, and I'm not saying I know all the answers. I think it'd be good to have a really good discussion about that, and I've touched on 4 or 5 different people about that topic.
I think that that's an excellent point, which is why when we publish the recordings, I suggest that you listen to the conversations on design space exploration, because that was exactly what that was designed to do. And there was a lot of that here, and it just wasn't well framed to point you to it. Dave?
Let's go back to COFES. How many people even remember what COFES stands for? It's the Congress on the Future of Engineering Software. And we haven't really been talking about the future of engineering software, except for the comment that was just made of how do we put it earlier in the design process.
Rick?
I want to say 2 things. One has to do with the discussion we had on fragility, and what I want to suggest is we kind of focus that concept of fragility on the fragility of the systems that we have and the systems that we design. And I think there's value to also think about the interfaces to the human environment that these systems have, and to think about how we can make that transition from one generation to another generation to another generation of capabilities and design concepts a lot easier for the human user. So I'm now saying the fragility of the human interface is a very key thing to be concerned about. And the other, in light of the design space, what I miss in system engineering is nobody teaches design quality. Nobody teaches you how to be Frank Lloyd Wright. Nobody takes you to Juilliard and teaches you how to be an expert musician. And the tools that we have in the engineering design space don't help at all in
generating innovative ideas or generating and helping to guide people toward high quality designs.
Behind you.
One point on the agility notion is that the literature is full of a lot of stuff about agile development, and people are struggling to go do agile development. I think it's very important for you to understand that agile development does not generate agile systems. So you paint yourself into a corner quicker is all. Okay. Second point about what we was talking about that we haven't today, and I think that is a thing called test and evaluation. As you get up in the right-hand quadrant with larger scale, rapidly changing systems, the people who have been doing test and evaluation for years simply don't know how to do test and evaluation of those kinds of changing systems.
Okay, and the last comment will be from Dave.
So, Brad, you asked what could we be talking about at this particular forum? And I think you set a really nice precedent by having a number of people who are under 30 speaking. What we haven't really talked about at all is the influence of that generation of people on how the overall design and development process will change, and therefore impact the software systems and the evolution of those software systems rather than the converse.
So that is a perfect close to lead in, because what I wanted to get to, I owe you plenty. What I wanted to get to is, when I started in this business, I was much younger. And I sat on the bus next to this formerly portly, but he was portly at the time, gentleman with a great big white beard who looked like Santa Claus. And we talked for an hour and a half. And we were going to the first MicroCAD forum. And we got out of the bus, and I went up, and as I always do, I sat front row center, and he got up and he walked with me, which I thought was weird because nobody else sits up, except that he went to the podium and gave the keynote speech, never giving me the idea that he was the person who was involved in that. And what Joel did for me was he told some other people, I don't know why, that I knew what I was talking about. And what we're trying to do here with the young people that we bring in is to do for them what Joel did for me. The other piece that I want to do is that I'm not as young as I used to be, and it's taken a very, very long time to understand that I am never going to understand the way my kids understand the way the new things are happening. There's some things that I can absorb, but at some point in time, my metaphors break down and I cannot incorporate the way they deal with it. And I have to recognize the fact that what they're doing, while it's different, isn't necessarily not right. And that the way, what they are doing, I don't have to understand it or incorporate it, I just have to accept the fact that it's going to change the way I need to think about the way things are going to be. And I think that that's absolutely critical that we not keep our own frame of reference or our own context and incorporate the context of the millennials and the ones coming after them in our thinking as we think forward. And I'll hand the... Peter?
Well, I just want to just add one thing, much of the same thing. One of the things that I just love about this event is that it's hard for me to imagine a room filled with more cool people and so much human capital in one place. And it's an absolute delight to do that. And I think one of the reasons, and maybe just another point about the human capital, it's so great. You know, I have this kind of rule of thumb. It takes 3 times, even if you're paying attention, to do anything right. You know, the first time you screw up the big stuff, the second time you screw up the little thing, and if you've been paying attention, you're John Herstick and you launch SolidWorks or something like that. Or it's, you know, Windows 1, 2, 3 or something like that. So there's a tremendous value in experience and new ideas put together. And yet what we find so many times is that with all this incredible experience, incredible business acumen and the rest of that, sometimes when we get together once a year, we kind of, I mean, it's great to see each other, but we fall into like old habits of like, how come we're only got 7% growth this year and stuff like that. So what I would suggest is that maybe we find a way, and there was a cloud sourcing suggestion or something, of somehow taking this human capital, this amazing resource, and find a way, maybe once a year or something like that, to think about something new, to maybe, you know, spend a little more time talking about fragility or something like that. Find some way of doing that so when we come back next year, we jump into that new discussion rather than fall into the old habit of, so how's your Fortran with what 5 code doing these days? So just a thought, and I just want to applaud everyone here for the amazing contributions that you make to the entire experience. I want to thank Brad and the whole crew for making this happen, but maybe there's a way to have just a little bite of COFES once a month that would prepare us even better to come back in a year and really further enrich what is already a very rich experience. So that's just a thought, that I'll leave it. And Brad,
we're not done yet. Okay. So in planning this, last year Monica was up here and did a great job making sure that the conversation worked. And Monica wasn't available this year because she's out watching her husband in a canoe or something along those lines. But Jim Brown, come on up, Jim.
Hey, Jim.
So Jim volunteered.
Yeah, he and Ferris volunteered.
Jim volunteered to step in for Monica and hold my hand in this session. And because while we had all hoped that Peter would come back to COFES, none of us really expected that was realistic. And I want to give Jim a round of applause for holding that spot and being able to, but I've also asked Jim to take the 5 key takeaways from this conversation and summarize them.
Do you want me just behind here? Or?
You can, right there.
All right. Thank you, Brad. And so in terms of 5 takeaways, and these aren't necessarily my 5 key takeaways, some are, but trying to reflect back a little bit of what I heard through this Congress and earlier. In terms of resilience, I think, you know, maybe defining, and Brad, you had a definition in your head, but I think knowing that, you know, thriving when design conditions change, right, is something we can all think about and take action on going forward, and looking at, you know, this resistance to disruption and recovery, right, and you know, losing a wing and being able to fly home gracefully is a great example of that. And I think one of the things that might be a takeaway from this would be to look at, you know, either in you're helping somebody design a product, or you designing your software, or you designing your product, looking at the strategies for resilience. And that was one of the things I thought was really interesting, and some of them Peter pointed out are a little bit contradictory, but not necessarily looking at the way the you know 10,000-year clock was built, because maybe those answers don't work for anybody, but maybe looking at each of those different strategies and what can we do to either help design better physical products or better software products using those strategies. So I think that's a takeaway that people could probably use. Consistent theme that I've heard throughout, you know, the last at least 2 COFES. COFES, COFESes, COFUS. Is there?
COFI.
COFI, I don't know. Is the millennials or the next generation and the younger generation. And we've had a couple of good conversations. Some of them actually were around social networking and the fact that social networking was coming in. But we heard that a couple of times again, and I think the focus needs to be, as someone mentioned, what needs to change in our engineering software based on changes to the design process, based on the changes to the way that millennials aren't going to ring a doorbell. They're going to text and say, I'm right out front, and those sorts of things. What are those kind of changes, and then what does that mean to us as an engineering software industry? Other than the fact that obviously we need to get a lot more of those people into our industry. Moving around here, I guess one thing, looking at Peter's presentation. First of all, Peter, I thought you said something brilliant that in terms of a definition of resilience. Peter, stand up. I mean, come on. And Peter's matrix that he put together about the thing I took away from that, and it may not be exactly what was extended, but what I think I heard from everybody is that we're taking a broader view at COFES. I remember a couple of first congresses that I was in, and it was about design standards and interoperability, and it was a very narrow focus.
First time that word this conference.
Right.
Hey, yeah, that's right.
and I think we've taken a broader view, and COFES has taken a broader view over time, and that taking on that look at more stakeholders, and accepting that we don't know all the answers. That this group does not know all the answers, and accepting and embracing that uncertainty does drive to sustainability, and maybe of sustainability of products, but maybe also of our market, right? I did learn also that chlorine from the pool does impact the performance of those keys with the little strip on, and that when you walk very wet to the front desk and say, my key doesn't work, and they say, where's your wallet? Anyway, lessons learned, right? One of the things that I heard bits and pieces about, the cloud. We really, there's still different definitions of the cloud. We really don't know what it is. Lots of people in here are doing different things with the cloud and trying different things, and we're experimenting. It's early. We're learning, right? And same with mobile. Same with big data or data exhaust. Same with we had some great conversations today on additive technology. This is not a boring time for the engineering software industry. I mean, there is so much going on, and people are doing such interesting things. The last thing I would sort of close on as an observation, and I heard it a couple of times about the human interaction of COFES and what this is about. And one of the things that I would say is that this is one of those conferences you see people you don't see. You think about things that you don't necessarily think about other times, and things like meiotic parataxis. You hear about things that you may not even understand today or later. How does that even impact what you're doing? But it opens your mind. It focuses you on a few different things, and this is one of those conferences. I don't know for everybody else. You go back and you process it over time, and all those bits and pieces start to fall in place. And I don't know any other place that does that. And I'll echo what Peter said, it's the people in this room that are out there and doing cool stuff. And when we all come together and we figure out, wow, you're doing that, and you're doing that, and you're doing that, this industry is really moving and doing some exciting things. So anyway, those are my thoughts.
Jim, can we have a round of applause for Jim? Peter, stand up. Or not. So, over the last several years that we've had the theme for COFES, we've had a theme that focuses on technology. We've had It's the Economy, Stupid. We've had our Innovate button and focus on innovation. We had a theme focused on complexity. Last year, we heard Richard Riff talk about risk, and this year we heard Xander talk about resilience. But the bottom line is, the reason that we are here is to understand, build, and grow both our vision and strategy. And I hope that as we move forward and this list gets longer and things roll off the top, that we continue to remember that the reason that we're here and we are effective at it is to increase our understanding, grow our vision, and move our strategy forward. And with that, I'd like to invite you all to join us at COFES Russia in less than 7 weeks. When I get back to the office, all of you will receive an invitation via email. There's still, for those of you who don't have visas, there's still enough time to do that. It will be a very interesting conversation. It will not be the same conversation here. The theme for COFES Russia is, what are the global trends and how are they going to impact Russia? And we have a great set of, many of you who come here every year are also going over there with us. And many of you from Russia who are part of the Russian community, the Russian developer community, have come here to COFES, and we look for you to lead the way for us when we are in St. Petersburg, right across the street from the Grand Palace of Peter the Great. And not to forget, in September or October of next year, you'll receive your invitation via postal mail for COFES 2014, April 24th through 27th. So we're going to be 2 weeks hotter in the year. And with that, I want to thank you all. I really appreciate the fact that you spend the weekend with us, and invite you to join us for the reception out by the terrazza. Thank you.
Thank you, Brad.